Oh, hello everybody. Welcome back. Just taking a break. Abject lesson here in number one, coding. Coding for too many hours in a row and also switching between languages back and forth. Read things carefully. I attempted this problem using a brute force technique, and that may have been well and fine and good and all, but completely misread the directions here. Okay, I'll explain what happened and what should have happened. Okay, this is a problem for Java and on the CodingBat website for Logic2 section, which nobody asked about during office hours or during class. So this Logic2 section, there's the first one in here. It's called makeBricks, and it says we want to make a row of bricks, one brick after the other, that is a certain number of inches long, a goal number of inches long. So maybe we want to make an 8-inch long row of bricks, right? And we have a number of small bricks and big bricks. And I thought, oh well, you know, here's the size of the small bricks, and here's the size of the big bricks. And can we get to 8 from using 3s and 1s? That's not what we're doing entirely. What we're saying is we have 3 bricks that are 1 inch long and 1 brick that's 5 inches long. So can you get 8 by using a 5-inch brick and some 3-inch bricks? And the answer is yes. Yes, you can. Yes, you can. You know, you have 1 5-inch brick and 3 1-inch bricks. That makes 8. This is 1 5-inch brick and 3 1-inch bricks. And that won't get you to 9. Okay? Now, be careful, because it's not that it has to wind up exactly using all the bricks, right? So, you know, if it was using the exact number of bricks that you have, then this would be a really, really super easy solution, right? You just say like, well, okay, you know, 3 times 1 plus 1 times 5, is that 8? Great. The last one, if we used all the bricks, we'd have 3 inches here, right? Because we have 3 1-inch bricks, and we have 2 5-inch bricks. So that's 2 times 5, 10 inches, plus 3 times 1, 3 inches. So 10 inches plus 3 inches is 13 inches. So, but you'll notice it's true, right? Which means we can make 10 inches of brick. We're just not going to use the 1-inch bricks at all, and we're going to say, we'll use the 2 5-inch bricks, put those two together, and you get 10 inches, and throw out the small bricks, because we don't even need them. So that's why this is returning true here. Okay? So, let's change this up a little, right? If we say that we have 2 loops, nested loops, again, this is brute force version, right? Let me get rid of this, because this is going to be all wrong, okay? All wrong, right? And all wrong, okay? But basically, we might, as a brute force technique, just loop through with each of our nested loops the number of bricks that we have. So that is looping through small and looping through big. Okay, so we can count through from 0 to the number of small bricks and count through from 0 to the number of big bricks, and each time add 1 to the number of bricks we're using. And as long as snum, the number of small bricks we're using, and bnum, the number of big bricks we're using, as long as we don't go past the number of bricks we actually have, small and big, then we're good. Okay? So, these combinations of bricks that we're using, well, if we have 1-inch bricks, well, it's just, you know, number of bricks we're using times 1, plus for the big bricks, each of those bricks is 5 inches long, so if we multiply that by 5, that will give us the length of the combined small bricks we're using, and the number of large bricks we're using, and if that gives us the goal, then we've won, right? Let's see if this works. Boom, okay? And remember, I'm saying this is a brute force technique. Uh-oh, we'll get to that in a second. It's a brute force technique because we're literally just trying out every single combination between using none of the small bricks to as many as we have, and the same thing with the big bricks, going from saying hey, if we're on this first pass of the outer loop and we're not using any small bricks, can we use no big bricks, one big brick, two big bricks, and so on? And then the outer loop will go to 1, and we'll say, well, let's see, if we use one small brick, will that make it if we use no big bricks, one big brick, two big bricks, and so on? So that's brute force. And so you can see for a small number of bricks, this works. It's fine. We can do that. We can use brute force, and we'll get the solution pretty quickly. However, what if the number is really large? What if we have 1 and a bunch of zeros? What's this, 6 zeros here? Well, I say it's going. What if we had 1 million small bricks and 1,000 big bricks, and we were trying to get to this number? And the expectation is that's true. It will actually work, but we don't have enough time to figure that out brute force-wise. Oh well. Anyway, if anybody has any questions on the non-brute force method, send me an email or come to office hours. Otherwise, you can think for a little bit about how to do this with a non-brute force method, which is what it's saying up here, right? This is a little harder than it looks and can be done without any loops. In fact, as you're seeing, they don't want you to use loops, because if you use loops, it takes too long if you have a bunch of bricks. And if you have a large construction project, you got a lot of bricks. Okay, so I'm going to pause this on my end, and you pause it on your end, and see if you can come up with the non-brute force, the tricky, little harder, without any loops version of this code. Thinking about it? Have you really been thinking about it? Do you have more than just these 3 lines of code, which leaves a gigantic blank there? Keep thinking. Pause. Oh yeah, hey, you're still thinking, aren't you? Or are you? Maybe you solved it already. So anyway, maybe a small hint. Maybe this will help you. Maybe it won't. What if you used all of the small bricks and all of the big bricks, and you figure out how much more is that length if you use all the bricks than the actual goal? And that kind of gives you a variable, an amount, how much, if you used every brick, how much extra brick do you have, right? So think about that. I'm going to leave it at that because, gosh, I've been sitting at this computer so long. Anyway, waiting, and I'm still waiting. So, send me a solution and explain it. Present in class, extra bonus. Anyway, that's it for tonight. Thank you.